Have you ever wondered what really makes an application succeed while another just collapses? Well, today we're going to dive into the core ideas from one of the most important books in software engineering, Designing Data-Intensive Applications, to figure that out.
So yeah, why do so many apps fail? It's so easy to point to a lack of features or maybe a bad marketing campaign. And sure, those things matter. But often, the real culprit is hiding somewhere much deeper, buried in the very foundation of the system.
Think about the apps you use every single day. Their success isn't just about the cool things they do, it's about how they do them. It all comes down to a few core principles that are, honestly, pretty easy to overlook, but are absolutely critical to get right. All right, so let's set the stage. The internet didn't just get a little bigger, it completely transformed. We went from simple websites serving up pages to these massive global apps that have to handle billions of interactions every day. Suddenly, the old rulebook for how to build things was totally out the window. This huge explosion in scale brought a ton of new tech and buzzwords, right? No SQL was everywhere. But here's the deal. As engineers, we can't just chase trends. To build something that's actually good, you've got to understand the why behind it all, the real trade-offs. And that's what we're going to unpack. So let's kick things off with the first, and you could argue the most important of the three core principles: reliability. Because, let's be honest, if the app doesn't work, nothing else really matters, does it? And I love the book's definition for this. It's so simple and so smart. Reliability isn't about pretending things will never go wrong, because they will. That's impossible. It's about building a system that expects failure and just keeps on chugging along correctly anyway. And these things that go wrong usually fall into three main buckets. First, you've got your classic hardware faults. A server dies, a hard drive fails, that stuff is going to happen. Then you have the really sneaky ones, software errors. These are the systematic bugs that might hide in your code for months before they cause chaos. And finally, there's us, human error. Yep, it's inevitable. A truly reliable system has to be ready for all three. So here's the bottom line. Reliability is all about the user. When you open an app, you just expect it to work. You don't know and you don't care that a server in Virginia is on fire. A great, reliable system is like a good stage crew in a play. It hides all the chaos happening backstage so the audience can just enjoy the show. Okay, so you've built a reliable system. Amazing. But now, a new problem pops up, and it's actually a pretty good problem to have. This brings us to principle number 2, scalability. This is all about what happens when you get popular. Like really popular. Scalability just means having a plan for growth. It means that as you get more users, more data, more traffic, you have a sensible strategy to deal with it. You don't need a system built for 1 billion users on day one. You just need a clear path to get there when the time comes. And there are 2 basic ways to do this. You can scale up, which is basically just buying a bigger, faster, more powerful machine. Think of it like swapping the engine in your car for a giant V8. Or you can scale out, where you just add more machines. Instead of one huge truck, you get a whole fleet of smaller vans. This single choice, scaling up versus scaling out, is a huge fork in the road for your system. Here's a fantastic real-world take on this from Amazon. They realized that trying to make the user experience perfect for 9,999 out of 10,000 users was just way too expensive. But making sure the experience was great for 99 out of 100 people, that was the sweet spot. That was absolutely essential for business. It's a great reminder that scalability isn't about perfection. It's about making smart choices. So building something that's reliable and scalable is a huge accomplishment, but it's only half the battle. If you can't manage it over the long haul, all you've really done is build a very powerful, very expensive headache. And this brings us to our third principle, maintainability. This one is all about the people. Just think about it. The people who write the code on day one are rarely the same people fixing it 5 years later. So maintainability means you're building software in a way that your future colleagues can actually understand it, fix it, and add to it without wanting to pull their hair out. It's about being kind to your future self. And the number one enemy of maintainability is complexity. The book uses this amazing phrase to describe it: a big ball of mud. Oh man, we've all seen a project like this, right? It's so tangled and confusing that you're scared to change a single line of code. That's a big ball of mud. So how do we fight back against the mud? Well, one of our best weapons is abstraction. It sounds complicated, but the idea is simple. Hide the messy details. A good abstraction is like the gas pedal in your car. You don't need to know how the fuel injection system works, you just need to know that when you press the pedal, the car goes. It's a clean, simple interface.
And this is why it's so important. Ultimately, good maintainability is the difference between a team that's building the future and a team that's just stuck fighting fires in the present. One team is creating value, and the other is just trying to keep the lights on. All right, we've covered the three big technical principles, but there's one last really crucial idea we need to talk about. Because when we build these incredibly powerful systems, it comes with a responsibility that goes way beyond the code. This quote from the book it really hits home. The systems we build have real consequences in the world, for better or for worse. And as the people building them, we have a duty, an ethical responsibility to think really hard about that impact. It is so easy to see data as just numbers in a database, abstract bits and bytes, but we can never, ever forget that behind those data points are real people. It's their behavior, their identity, their lives, and that data has to be treated with humanity and with respect. So as we wrap up, I just want to leave you with this one question. When we apply these principles, reliability, scalability, and maintainability, we're not just building apps. We are quite literally building the world of tomorrow. So the real question is, what kind of world do we want that to be?